I make no claim that anything in this presentation can cure any form of illness. However, the very simple colloidal silver, which is just very tiny charged particles of pure silver suspended in distilled water, has been very helpful in the past. Colloidal silver has cured many terminally ill cancer patients. It has eliminated swine flu, Lyme's disease, typhus, malaria, cholera, and anemic dysentery. It converts cancer cells back into healthy cells, and it has been successful in dealing with osteomyelitis, diabetes, and severe tissue damage. It has no side effects, and it's easy to make. The first requirement is distilled water, and a cheap parts per million meter can confirm the quality of the water. It should read 0 parts per million before the electrolysis takes place. The second requirement is 99% pure silver wire, a battery, a glass container, a non-metallic stirrer, and 2 connecting wires. The arrangement is very simple. The water is placed in a glass container, and 2 pieces of silver wire are clipped to it so that they form electrodes, which are perhaps half an inch apart. The battery is clipped to the electrode wires, and the water is stirred while the colloidal silver is being created. The battery can be any type. It takes only a few minutes to make colloidal silver, and the water should be stirred all the time. The target is 10 parts per million, and the ppm meter shows you when you've reached that concentration. The electrode connected to the battery minus terminal will become covered with a black deposit, which may need to be wiped off with a fresh tissue during the preparation of the colloidal silver. When you store the silver wire away, make sure it's away from the air so that it doesn't oxidize. Placing about 10 cc's of colloidal silver onto the tongue for a period of a minute or so, several times per day, is effective, as the silver particles enter the bloodstream, and that's easy to do through the tissue under the tongue, and that treats everywhere in the body at the same time. Using a nebulizer is also effective when treating a lung problem. Another highly thought of treatment is the Bob Beck protocol, where he supplements taking colloidal silver with a low frequency electronic pulse applied to each wrist. His document is at http://www.free-energy-info.com/beck.pdf, and his equipment can be constructed quite easily. This is his circuit here. If you're not familiar with circuitry, Chapter 12 in my ebook will teach you the basics and show you how to make things. But this circuit has got 3 9-volt batteries to form 27 volts, an on-off switch, 2 100k resistors, which give you a point in the middle which is half of the applied voltage. So you got roughly half of 27 volts at that point. You then have an LM358 integrated circuit chip as the heart of the operation. It's a very slick chip. It's low cost, very versatile, very robust, and it's wired here to generate both a signal and a buffer. So it pushes out a signal through pin number 7, which goes to a variable resistor of 100k and an 820 ohm resistor to make sure that you have at least some resistance there, and that goes to an earpiece socket, and the earpiece socket plugs into an ordinary 3.5mm plug, which has wires out of it that you put on the ends of wrist electrodes, which are easy to make. That is the basis of the circuit itself. A slick operation that he does on this is he uses a two-color LED, light emitting diode, and he uses two 18-volt Zener diodes there, and the result of that is that you get an alternately flashing red and green light coming from the LED to show you that the system is working right. If you're not familiar with the symbols for a plug-in socket of the 3.5mm type, this is what the socket looks like, that's what the plug looks like, and these are the same connections shown on a circuit diagram. You may find it easier to understand the circuit if you look at the circuit diagram inside the integrated circuit. You have the midpoint voltage being fed in as a reference to pin number 3, and you have two resistors and a capacitor forming an oscillator circuit which oscillates about 4 times a second. That's fed on then directly to the second operational amplifier, which is inside the same single small integrated circuit chip, and that's the way that the circuit actually operates. It's very simple, very robust, and very low cost. Now, the physical construction of the unit could be done like this. This is the circuit layout that I used when I built the one that I have, and it has been very satisfactory. It's very neat, and it can be housed in a plastic box which is only 100 by 70 by 40 millimeters, including the batteries and the variable resistor and the LED and the on-off switch. It generates a signal which is 50 volts peak to peak, and so you need to adjust the variable resistor so that you can feel the pulses but they don't hurt, and if you turn the variable resistor up high enough they will hurt. You can use a broad elastic strip to hold the entire unit to your forearm, and two other elastic loops to hold an electrode to each wrist. Treatment is suggested to be 2 hour-long sessions, or let me rephrase that. Treatment is intended to be a 2-hour-long session, and it's suggested that it happens daily. I have found it to be very effective. Now, around 1920, George Lachowski produced a very effective treatment method. An American developer has kindly shared the method which he used to replicate this equipment. The idea is to arrange two aerial arrays to transmit healing frequencies to the patient. The patient sits between the two aerial arrays, and the transmission from one aerial to the other passes through the patient's body and is very beneficial. The frequencies of the waves transmitted between the aerials is controlled by the lengths of the aerial tubes, and there are a dozen different aerial tubes, and that creates a dozen different frequencies, and that is a sophisticated way of doing what you're aimed at doing. These aerials are tied together with string in 4 directions to hold them as a particular unit, and they're bolted to a drive coil which is in a plastic housing and is attached there and there. The two aerials are constructed from flexible copper pipe, which is just as well because it's extremely difficult to bend thicker copper pipe smoothly and evenly. It's important that a system of this type has a very effective earth connection, and that earth connection must not be part of the main supply. In this case, several different types of metal are used in the earthing. You have the box housing the circuitry, you have the coil which drives the aerial, supporting the aerial, and that's held in braces off the box itself, which has got wheels on so you can move it around easily. But the earth connection is through a fairly short wire to an area of ground which is 6 feet by 3 feet, and in that area there are 6 earthing rods. These are 6 foot long and half an inch, which is 12 millimeters in diameter, and those rods are driven into the ground. Now you've got a copper rod, an aluminium rod, a zinc plated copper rod, an iron rod, a brass rod, and a second copper rod. The circuit used looks complicated, but it really isn't, and it's easier to understand when it's broken down into parts. The first part of this circuit is just the power supply from the mains, along with protection features. So you have the main supply, which in America is 110 volts alternating current. You have a foot operated switch, which allows the patient to switch the system off instantly at any time. The fuse here protects against a short circuit anywhere in the equipment. The filter cleans up the power supply, and the magnetic switch is mounted on the operator's console so that the operator can switch off the equipment instantly, although I've never heard of that being needed. The fan and its speed controller are only used for keeping the equipment cool, and the timer is just a simple mechanical timer which allows you to set a treatment period of any time. It's usually 15 minutes. And finally, the neon bulb here is just to show you that everything up to that point is working correctly. All of this is commercially available. The commercial units look like this. You have the magnetic switch, you have the speed controller for the fan, you have the fan itself, you have the neon bulb, you have a mechanical timer, and you have the mains filter. And those are the units that mesh together to create the first part of the circuit. Now the working part of the circuit is this bit, and while that may look complicated, it really isn't. The first item there is a variac, which is a variable voltage transformer, and that allows the voltage which is applied to the rest of the circuit to be controlled, and you can see the current on this ammeter here, and you can see the voltage being applied on this voltmeter here. That means that the actual operational part of the circuit is only 14 components. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The NST here stands for the neon sign transformer, and that's a high voltage transformer, and it steps the voltage up to thousands of volts, so that there's a high value of voltage on capacitor C2. That's when it passes through 2 chokes which stop the pulses being excessive and passes the DC voltage through more than anything else, and through the 2 resistors, and that builds up a sizable voltage on the capacitor. Now if anything goes wrong, there is a spark gap with a 12 millimeter gap in it. That's a half an inch, and that means that if the voltage really gets to be excessive for some reason, then that will fire and keep things within reasonable limits. But the objective here is to build up voltage on capacitor C2, which is straightforward enough. Now what happens then is a spark gap discharges capacitor C2 repeatedly, and the discharge is fed via these 2 capacitors C3 and C4 and through 2 driving coils to each of the 2 aerial arrays. and that is the heart and basis of the system. The design of this type of equipment means that the physical construction is a major factor. Now, the magnetic orientation of the two aerials is supposed to be on a north-south line, with a transmitting aerial on the north side. Now, the size of the actual rings in your copper pipe aerial array are important, and you can see from here the diameters of the circles being defined, and the thickness of the pipe, the diameter of the pipe, the depth of a groove that you would cut in a setting up board, and how much that you need to actually buy the stuff when you're ordering from China. Now, the aerial itself is built on a wooden board, which is good quality wood, and has the groove positions marked out on it, and they're then grooved using a chisel so that you have the exact position and shape and size that you need for each of the rings. That allows you to build up the two aerial arrays that you need to use with this equipment. This is one aerial array, the receiving one. This is the transmitting aerial array attached to the box which holds all of the circuitry. When the aerial is placed in the grooves of the board and finished off, this one shows as brass spheres at the end of the copper pipes. That's not an essential feature, but it is a nice feature. Every circle of the copper pipe radiates its own specific frequency across the space between the two completed aerials. So the waveform used to benefit the patient is a composite waveform of 12 different frequencies. The full details for construction of use of this are in www.freeenergyinfo.com, capital PJK lowercase book.pdf. That's a free download. You'll find the details in chapter 20. The construction details are straightforward, ranging from the case, where you have the doors and the sides, the various cutouts for ventilators, and the sloping top panel, the base panel, and so on. All of the components are there, and you can see from the dimensions here what size you need to make the particular device itself. The box will end up having a hinge door on one side and a solid face on the other side, and a sloping operator working surface between the two sides, and these are ventilator slots cut into the sides so that the fan that's cooling the equipment can blow the hot air out of the sides of the equipment. This is the layout of the prototype used by the constructor here, and you've got the voltmeter and the ammeter, the neon bulb, your emergency stop, which looks very professional, the knob for setting the voltage, and the fan speed control. The spark gap adjustment, which we'll come to later, comes up through a hole in the top panel there, and mechanical timer is just mounted on the bottom right corner. That's the arrangement for the actual equipment itself, and here you can see the pieces of equipment built inside the housing itself. The physical wiring is not difficult at all. You have a foot switch which switches on and switches off each time you press this foot switch. You've got an insulating box inside which the mains comes and is clamped there, passes through a 5 amp fuse, and goes to the mains filter. The mains filter goes through the on-off switch, foot switch, and through the operator's emergency stop switch, and it then powers in the fan speed controller, and the timer, and the neon shows that it's actually working. The output then goes to the variac. The variac is a variable alternating current transformer. This one shown here is the type that was used in this prototype. It's available on eBay, as is pretty much everything. You have two capacitors that are used in the actual operation. They're available as well. The more difficult ones are these here. This is a so-called doorknob capacitor. It's a high voltage ceramic capacitor. 30,000 volts it can handle, and it's 100 picofarads. Another version that's available is 15 kilovolts and 5300 picofarads. There are specific details on how to assemble, construct and interconnect the components. The resistors that are in this circuit carry a lot of power, so even though they're 1K, their 25 watt dissipation is specified, which is why they have a metal case that you can bolt to a heatsink if you wish. However, you need to understand that this is not a toy. This is a serious circuit connected to the mains, and just in the same way that if you take the main socket off the wall of your building and mess around with the connections inside, you need to be very careful because it can kill you. And the bit inside this red rectangle here is the dangerous section, dangerous to human beings fooling around with it. It's a low frequency, high voltage, which could kill you if you're careless. So let me stress that this presentation is for information purposes only, and must not be considered to be a recommendation that you should actually construct this device. In spite of the very high specification of the capacitors that have been shown above, we have to combine them together to form an even more impressive arrangement of capacitor, and this is the way that was done in the prototype. You have the capacitors connected by a copper strip to carry current very effectively, and they're connected then with a high voltage wire, which is itself insulated, to where they're needed in the circuit, in the physical construction of the circuit. A spark gap is constructed using ultra-high molecular weight polythene plastic chopping board, which is cut to the shape that you need. This is the chopping board here, and it's had a rectangle cut out of the middle, and mounted on it are two aluminium brackets. This aluminium bracket is bolted to the board. This one is left able to slide on the board, and the spark gap goes through the first gap, across through the second gap, across through the third gap, across and through the fourth gap. Now all of those spark gaps fire at the same instant, and you can adjust them using a threaded rod with a knob on it, so that the distance between the two metal spark gap ends is set to the spacing that you want. You can adjust this spacing during treatment if you wish. This is quite a neat way of doing the spark gap. Spark gaps made in that fashion tend to be quieter than just using a single spark gap. The spark gap is built from tungsten rods which are set into aluminium cylinders, both of which are available on the web. And the completed unit then looks like this. You have a knob and an insulating guide, which then is attached to the threaded rod, which moves the bottom bracket, which is a little hard to see, and the top bracket here is attached to the actual board itself. Now the coils which drive the antennas are made of two different winding materials. The first one is thick copper pipe, which is done with 6 1/3 turns typically. It's wound the way you wouldn't expect it to be wound. Which is clockwise. That means it goes down underneath what you're winding it round, up the far side and down on the side facing you, which is not a natural way to wind the coil, but it has different characteristics when you wind it in that way. That then comes into the start of a 300 turn coil, which is wound with 0.5mm diameter enameled solid copper wire, and the connections which are used to connect that coil to the actual aerial array needs to have plastic nuts rather than brass nuts, because if you don't do that you tend to get sparking occurring there, and it's not a good idea to have sparking there. When you're using this in treatment, you put a wooden stool for the patient between the antennas. Now, most treatments are about 15 minutes long, but it would be nice to know the level of transmission power between the two areas. That can be determined using a simple meter. A Philips TL6W33 fluorescent tube, which is 220mm long, that's 8.66 inches long, can be used as a detector. A 15-volt voltmeter is set up to show full scale deflection when 0.09 volts is applied to it. So you have to start by adjusting this preset resistor along with the meter to make sure that the meter is fully across its scale when you get 0.09 volts applied to the two of them. So these two together effectively make a voltmeter, which is aimed to give you full scale display for 0.09 volts. So when the preset is set correctly, then you can complete the circuit for the detector. You have your fluorescent tube and two diodes connecting each ends. That gives you a full bridge, 4 diode bridge connection to the meter. The unit is then placed between the two aerial arrays, and it will give a display of the strength of signal going between the two aerial arrays. These very brief presentation notes can be downloaded using the following link: http://www.freehealth.com/HEALTH or capital H lowercase EALTH .pdf. But a very much greater level of detail on building and using this equipment and related topics can be found in the free ebook, which is at www.freeenergyinfo.com/capital PJK lowercase BOOK.pdf. And you need to use capital letters where capital letters are shown in those two links.